Hi guys, and welcome back to the Inertia Education. Okay, thanks for your like and support for all of. Okay, now first of all, as per the yesterday's talk, okay, some of the peoples are demanding to have the lectures in Hindi and English. So now and onwards, we are going to have the conversation in the Hindi and as well as in English. Okay, but you will understand the things quite better. Okay, that is my promise. Fine, come on. So as per we have talked yesterday, okay, we are going to study about today the heat engine, okay, and the air conditioner plus the Carnot cycle. Okay, so let us start. Come on. So first of all, we are going to study the heat engine. Okay, so simply heat engines are the things, okay, which grasp the heat and give out the work done. Okay, so starting in the form of we for the exam point of view, you have to write just some of the small block diagram, and you can start here from the hot reservoir. At the hot reservoir, here is the prime mover again, okay, which is called as PM. Okay, and here it will be the cold reservoir. We have started from Q1. Here it is the work output. Okay, we can get the output in the format of work. Okay, and here it is the cold reservoir at the heat Q2. Okay, so the situation is isolated from each and everything. We are assuming that there is no loss of energy. So you can write here, as we can know that Q1 is the total summation of W and Q2. We can easily see that. So Q1 equals to what? Equals to W plus Q2. It is logically thing. Okay, if you go to understand that thing, if you see the machine of a juice, okay, you can conclude that you are taking some of the oranges, or you can take the sugar cane. Okay, at that time, what you get at the output, you can get the juice of the sugar cane and in the output, and some of the waste pieces of the sugar cane as the Q2, and what you are getting the input, the total summation of the juice and the waste of the sugar canes. Okay, so in the format of W, okay, you can get the juice, you can get the waste. If you combine both of them, you can get the original sugar cane. This is a simply example of the work input and output. Remember one more thing, if you are here adding something in the quantities of the physical quantities, okay, so you must know that the units are same. Okay, we are taking all of these three things in the joule. Okay, you can't add the different quantities in the same format. You have to add the same quantities. Fine, so you can write here now, moving forward, W is equals to Q1 minus Q2. Correct. Now we have to calculate the efficiency, which is denoted by eta. Eta is called as the efficiency is counted by output by input. From since the ninth standard, you can conclude these things. Okay, what we get in the output, we can get the work. Okay, so it is our work done, W by what you have given in the input, it is Q1. So you can write here Q1 minus Q2 upon Q1. You can see one father, two sons. It can be equally divided. So you can get the answer. Here it is 1 minus Q2 by Q1. Okay, there is no need to explain that Q2 is equals to ms delta T2 and Q1 is equals to ms delta T1, and ms will be chat. So you can have the answer 1 minus T2 by T1. Okay, which is shown in the figure. Now here you can see that the efficiency eta is always less than 1. Correct. Okay, where the condition is T1 is greater than T2. This is how simple as that. There is nothing much, not a big rocket science. It is simplest thing. Now we are going to study the air conditioner. Okay, we are going to study the air conditioner. Same block diagram, same thing, just little bit change in this situation. Here it is hot reservoir, again here it is prime mover. Now we have to give the work here. Okay, this is the only change. Okay, no, T1 is also greater than T2. Same thing. Okay, here it is also cold reservoir. Here it is Q1 heat at the higher and Q2 must be at lower. So now again, now we are what we are having. We are having the work output here. You can see the air conditioner. What it does the room temperature colder than the temperature of the surroundings. Okay, so the work done is inside the room. So now the output will be Q2. You have to switch on the things. You are working from taking the work from motors. So you are inputting the work in the format of W. So now output will be Q2. Okay, so what will happen, that Q2 must be summation of W plus Q1. So you can write here W equals to Q2 minus Q1. Again efficiency eta equals to output by input. Again it will be what? It will be, what is your output now? It is Q2. So it is written here Q2 by, what is your input? It is W. So it will be Q2 by Q2 minus Q1. Okay, by these things you can also put the T2 minus T1. There is no rocket science. Okay, you can already understood all those things by the format of this here, T2 minus T1. Okay, write it by yourself. Now you can see that it is, the coefficient is denoted by alpha. Okay, the coefficient of the efficiency is denoted by alpha. Now Q2 minus Q1, you can see that by putting both of the values, you can see that alpha is always greater than 1. Okay, this is less than 1 is called as the coefficient of performance, which is denoted by beta. Okay, there are two type of coefficient of performance, which is shortly written by COP. Okay, coefficient of what? Coefficient of cold. It is just the subtraction of this by this and this by this. Not a big deal. Okay, take the screenshot, write it down by yourself, and understood the things better. Okay, by observing the things around you. Now we are going to study the Carnot cycle. Okay, so must remember that the Carnot cycle is ideal, as per we have talked about in our last lecture. Okay, I will share the link below. Okay, so you can easily reach to the last lectures. Fine, come on. Now first is Carnot cycle. We have to draw the PV diagram of the Carnot cycle. Here is the PV diagram of Carnot cycle. Okay, I will do it little bit lower so we can write properly here. Come on. Okay, here it is. We can start from here. It is P1, V1 and T1. I am writing the T1 from the outside. Okay, so we can understood that things better. Okay, now it is the isothermal expansion first. Okay, start from here. It is called as the adiabatic expansion. Here the coordinates are P2, V2, but it is isothermal, so temperature will remain constant again T1. Okay, at the same point here it is adiabatic, so temperature will change now with the pressure and volume. It is P3, V3, T2, and here at the end it will be again P4, V4, T2, because it is isothermal compression, and the last stroke is adiabatic compression. Correct? Okay, it is the diagram in the upper format. It is in the volume. It is a diagram of P and V with the T constant. Now you can write it here from step 1. Okay, you can start here from step 1. What is the step 1? It is isothermal expansion. Okay, first of all, to understood this thing, you have to study the piston cylinder arrangement. Okay, for the piston cylinder arrangement, you can see here I am drawing the piston and cylinder. Okay, in the cyclic process. So it is called as TDC, top dead center, and BDC, bottom dead center. Now come to understand this thing. First of all, as the piston goes down, okay, it starts the petrol and things, all of are suddenly put in here. Okay, it compresses. This is called as the isothermal compression. Okay, now the pressure rise. Okay, it expands. Okay, and at the point of the head, there becomes the adiabatic compression. Okay, at the time of the expansion from P1, V1, T1, okay, it gets fire. Okay, but at the simplest time, on the smaller notation of the fire, it pressure and volume comes to here from here, then the temperature comes to rise, then temperature rise, and there takes place of the adiabatic expansion. The system of the cycle takes place in the 4 format: suction, compression, expansion, and exhaust. Okay, this 4 strokes is remaining in all those 4 cycles, starting from here, second, third, and fourth. Again, this cycle goes on repeating. Okay, by this you can understand this better. Any of the, if you are using the compressor also, the compressor also works on this same phenomena. Okay, it can compress the air by this system only. Okay, but it works on the Rankine actually, not on the Carnot. But these are the assumptions which was taken from the Carnot cycles. Okay, so we are going to write now the Carnot cycles and the work done and its efficiency and however it works. Fine. So for the step 1, okay, we know that it is isothermal expansion from the point P1 V1 T1 to P2 V2 T1. Work done of the isothermal. I have told you to remember all those things. That's why it is W is equals to mu R T1 ln from final to initial. It is V2 by V1. Correct. Now for the step 2. Okay. Here it is step 2. You can write it is adiabatic expansion. What is it? Adiabatic expansion from P2 V2 T1 to P3 V3 T2. So you can write here what in the format? It is W is equals to mu R upon gamma minus 1, and it is from where to where? T2 to T1. So I can write it here T2 minus T1. It is as simple as that, nothing more bigger. Okay, in step 3, no need to worry about all those things. We can write simply in the format W equals to mu R T2 again now for the isothermal compression. Okay, so you can write here ln from where to where? It is V3 to V4. So where we have reached finally to V4. So we can write here V4 by V3, and last step 4. Okay, the last step 4, which is adiabatic compression from P4 V4 T2 to P1 V1 T1. So it will denoted by W equals to mu R upon gamma minus 1. Here it will be T1 because finally we have reached to T1 minus T2. Correct. Now what we can do? We can do the W equals to W1 plus W2 plus W3 plus W4. Okay, I have less space here, so you can write all those two things in this area. So mu R T1 ln what is it? V2 by V1. Correct. Okay, plus mu R upon gamma minus 1. It is T2 minus T1. Okay, next plus mu R T2 ln what we can write? The third V4 by V3. Okay, plus mu R upon gamma minus 1 T1 minus T2. Okay, I am writing this little bit like this. Now what if I common up the minus from this step? What it will happen? It will change from plus to minus. It will be here minus. This T1 will be minus and T2 will be plus. So you can have the same step like mu R gamma minus 1 T2 minus T1. Correct. Here it is minus, here it is plus. So you can all of them though cancel out all those things. Now finally what you have remained here? It is mu R T1 ln V2 by V1 plus mu R T2 ln V4 by V3. Got that? Okay. Now you have to put out all those values in the format of T. How to do? We are calculating here. Okay. Please pay attention a little bit more. Okay. We have to take the 2 steps of the adiabatic processes. What we have to do? The step of the adiabatic processes. It is the first. Okay. The steps are going from the first to another. Okay, the step, you can see here steps 2 and step 4 are of the adiabatic expansion and adiabatic compression. So I am writing here first of all step 2. Okay, it is step 2. You can take both of the PV raised to gamma equals to C, and if you else wanted to do is T V raised to gamma minus 1 equals to C, and I have remember you that you can put PV raised to gamma equals to C in the place of P1 V1 raised to gamma equals to P2 V2 raised to gamma. So same applicable for here. I am writing this because in the books of many it is given. So I can write here for the first step. Here it is T1 and V2. T1 V2 raised to gamma minus 1, and here it is T2 V3 raised to gamma minus 1. Correct? I am taking out the ratio of T1 by T2. It is V3 by V2 raised to gamma minus 1. Correct? Next step. Step 4. Again same situation for the step 4, T2 and V4. So T2 V4 raised to gamma minus 1 equals to, here it is T1 V1 raised to gamma minus 1. Again you can put out the ratio of T2 and T1. So V4 by V1 raised to gamma minus 1 equals to T1 by T2. Now you can put the T1 by T2, V3 by V4 ratio in the place of this. So it will be V4 V1 equals to V3 and V2. You can cancel out the power of both of the sides. Ultimately what you got, it's V4 by V3 equals to V1 by V2. Okay, correct? You can got this situation V2. So you can alternate these things also. If you alternate, you can get the twice the times. You can put this thing into this V1 by V2. You can also minus it out. Fine. So if you will minus it out, you can have T1 and T2 here. Now I am rubbing all those things. So if you put all those things into it, you can get the output by input. So for at the end you can got the output, it is equals to output by input, which is denoted by, do your calculation by your own self. I am not going to teach you the small things in it. Okay, it will be 1 minus T2 by T1. Okay, this will come your eta. Okay, it will be work done for the basic fundamental. Output will be given by W, means your total work done, and input will be your the W1. Okay, which we have calculated the first mu r ln V2 by V1. By putting all those situations, you have to do this by your own self. You can reach up to here. Okay, eta will be 1 minus T2 by T1. From this, what you can conclude that if the Carnot cycle just depend on the temperature difference. Okay, you can see it by your own self that there are just two quantities, none other than situations are toggling on bit. Fine. Okay, so it is depend only on the temperature. What it wanted to say to us that if there is the only temperature difference between any two substances, you can have the immediate work done right now. Okay, to there. Okay, you can transfer from heat from one place to another. You can put out some of the work in between that. Okay, so you can do better things by just having a temperature difference. Fine. Okay, you know the electrocouples and the thermocouples are working on the same phenomenon. Okay, the thermocouple, at the end of the thermocouple you have to take the two conductors. Okay, at the end of the two conductors there is a hot end and there is a cold end. You can easily know that there is a flow of electrons with the energies, okay, with the sum of the potential heading in it is transferred by this thing. So you can know that the temperature difference make a lot of variation and lot of work in its original format. Okay, thank you for watching. Bye, take care.